Good day, dear listener. My name is Aziz Latif Babatunde. I'll be making a presentation on this particular topic, subsea pipeline, material coating, and corrosion. So before we dive down to what this particular presentation is, I would like to examine what this topic is. Number one, it's discuss the various measures and factors to consider in selecting best material for uh, pipelines to meet up with subsea environmental conditions. One, to serve as a mitigation for corrosion control, and to ensure or to guarantee the flow assurance of to guarantee the flow of the fluid. Why this topic also look into the different mechanism of corrosion formation in pipelines, and how we can monitor them, how we can inspect them, and how we can correct them using different mechanisms. And also coating as a means by which we can bridge the direct interaction between the materials and the environment. So in this wise, this actually reduces the rate at which corrosion will occur in a material. And of course, what are these corrosion as earlier discussed? So corrosion is the ability of a material to return itself back to its ore with some due to some environmental interactions, so reactions. So, and all of these are going to be examined using as a parenthesis of subsea pipelines. So, in this introduction, in this presentation, I'll be discussing why pipelines are referred as the backbone of offshore energy infrastructure, because they enable the transportation of the resources, and therefore their designs must be paid a well attention to. And while we are designing them, we need to put into consideration the environment at which they will be operating, and the possibility of facing harsh situations or a very rapid corrosion of the metal in such environments. So, and of course, we have 4 basic scopes for this research. Number 1 is material selections. Number 1 is corrosion mechanism. Number 3 is coating system, and number 4 is catalytic protection. While we have this scope, we also have the objective that I wanted to meet with the project. Number 1 is to examine the different form of materials that are commonly used in subsea pipeline constructions, and through this we can dive into advancing such materials so that they can mitigate corrosion. And number 2 of the objective is to investigate the diverse corrosion mechanisms that threaten subsea pipelines. Now, and another objective is to explore the critical role of coating systems in mitigating corrosion. While also we'll be discussing the implementation and effectiveness of cathodic protection systems, and to highlight the importance of regular monitoring and inspection. So why is this very important? We can't just, even though we have created a mitigation like a control measures, we have selected best materials for our pipe, we have do the right coating, and everything that are in place, we still have to monitor and inspect our pipes at a periodic interval to keep the maintenance in place. Yeah. During the research process, I was able to consult several literatures, among which are these four literatures that individually discuss each of the scopes that are listed earlier. While the first one discusses the material selections, the factors to consider. So Brown J discuss coating of pipelines, while Tenaris, I pick from their expertise, some of their publications to explain further in my report how flood coating are being done. So while also we look at the modern ways of doing corrosion monitoring and the various methods that have been developed over time. So, and during the process of the research, we're able to depicts how electrochemical corrosion actually works. These pictures illustrate how electrochemical corrosion of steel occurs. And before this electrochemical corrosion could occur, what do we need? What are those things that must be in place? We must have an environment that is capable of ionizing the ions that made up a particular compound. So, and there might be presence of some oxidizing agents. These oxidizing agents might be oxygen, might be CO2, might be H2, like hydrogen gas, and the likes. And what happens when this oxide interacts with the surface of our steel? What happens? It ionizes, so they lose their metallic ion. And once they lose their metallic ion, what happens? They degrade. They return back to ore. So, and that's how critical and severe this could be in subsea environments. Yes, why that one is there. We also look at this system of coating, where the pipeline is flooded with the clothes, with the coating materials, and how are they flooded? They are going to quench there's a bath or a container that contains the coating material. Then the pipeline is quenched inside of it. And while that quenching takes place, it is now extruded out of the quenchant of the quench, then heated to ensure that a uniform thickness is maintained. So, and these are the illustration of how this is done. And with that, we look at the cathodic protection of pipe, where we have a kind of a current sending a continuous sending of a current to our pipe to resist corrosions. So yeah, and this is how the configuration typically used. The pipe will serve as a cathode, and a galvanic anode will be external. So will be like indirect contact with the pipe, and then a current will be linked, like a direct contact will be connected between the galvanic anode and the pipe. And when this continuous process keep repeating itself, they will be generating a resistance. So Yes, after a thorough investigation, we discovered that corrosion is very significant aspect that we need to control in corrosion in our pipelines. And to do that,